In this video, we will continue with integration of trigonometric functions. You will find this on page 530 in the Namibian AS-Level Mathematics textbook Y equals mx plus c to success. Let's look at another example, and this is a typical exam example. And they are mixing, so they are mixing differentiation, and it's actually to help you and then go to the integration. But let's start. So by differentiating cos x over sin x, show that if y is equal to cot x, then dy over dx is equal to negative cosec squared x. Okay, remember what is standing there? Differentiating. Okay, so if I differentiate, I must use the quotient rule. So I'm rewriting the denominator, I differentiate the numerator, minus. I rewrite the numerator, I differentiate the denominator, and over sin squared x. Okay, now I'm basically just going to differentiate. So please don't forget your rules. Go to chapter 11, to the summary, and just get the rules again. So it's negative sin x, and then minus cos, and sin becomes cos. Cos becomes negative sin. This is differentiation, not integration. Okay, if I simplify, I'm getting this. Now I take negative 1 out as a common factor, then I get this. Then I know that this is the identity is 1 and that negative is from the front. And then I'm getting this. Okay, so I did the quotient and there I arrive at that answer. Okay, now we go on. Now, by expressing cot square x in terms of cosec square x and using the results of part A, show that cot square x is this. Okay. Now, don't forget, this is also identity. You will find it. I don't know if you will find it on the formula sheet or you will find only, let's just check quickly if I have the formula sheet. I know it's here. Okay. Yes, let's just make it bigger. Come on. Okay. So if you look here on the formula sheet, you will also see that identity. Okay, so there, where is cot? There, cot square x, do you see, is equal to cosec square x minus 1. So you will find it on the formula sheet. That's nice. But that's coming from chapter 4 already. Okay, so basically I'm just going to substitute. Now, I said remember this. Now this is coming from chapter 11, derivatives of the reciprocal trigonometric functions. So if you look there, you're going to see, okay, now look here. This is, if you differentiate cot x, you get negative cosec square x. Okay, all of this, and you can go back to that page, 488. You can do it with the quotient rule, but don't do it too long. So rather just memorize that field. So I know that this is this. Okay, now remember, integration is the reverse. So if I reverse back, then if you see this one was a positive, let me show you there, and then it became a negative. Okay, so now if I make it a negative, then this one will just become a positive. So one must be positive and then negative. So negative cot square x will just be the negative, and the negative will just go into a positive. Okay, so as if I'm doing this, so it's cosec square x, there I am, cosec square, it will just be negative cot x. And then if I integrate a constant, I just put x. And now I substitute this. I substitute the top one in, I substitute the bottom one in. And then, okay, I want to show you, and I want to show you how to do this on two ways. You can either use chapter 10, if you must also memorize the basic graphs. So if you look on the basic graph, okay, there's cot, are you with me? And there, okay, if this was just pi, and this was pi over 2, and okay, so it's actually pi over 2. And what is pi over 2? It's just going to be 0. But can I say for example, you cannot recall this. I just want to show you also. You can also do it as, you know, cot is cos, is actually a cos, let's just get the pen correct. It's cos a half pi over sin a half pi. And then if you, because that graphs will be in your memory, okay, that's easier, or most of the times that will be easier to recall. So if you then, this is my two graphs, and I had it on the previous page also. I think let's just go to the previous page. So cos a half, what is cos a half? Oh, I made it so big, so now I must just make it first small. Okay, there, you can see. So what is cos a half? There, do you see the blue there? So that's 1. No, there is cos a half, that's 0. Do you see? What's sin a half? That is 1. So it's basically 0 over 1. Let's go back. So it's actually going to be 0 over 1, which will be 0. It doesn't matter as long as you come to that 0. There is this one, and then it's again cot a quarter. But remember what I said to you. You can look on the cot there, and that is basically going to be there. But again, you can do it as saying, okay, cos a quarter pi over sin a quarter pi. Okay, and this will be the best if you go from this. Can go to the graphs also, but E1 square root 2, because this is going to be pi over 4. So if I'm looking at it from this side, so it's going to be cos, so it's going to be 1 over square root 2 over, what is sin? 1 over square root 2. Do you see? It's exactly the same. And that is why you remember the negative is from the front, and there is your 1. That is going to be 1. Okay, so minus this, and then I basically just simplify. So this is becoming positive 1. That's what I got there. And this negative, this is going to be negative of pi plus a quarter pi. And if you simplify that, you're going to get that. Okay, and that's how you do. I always want to show you a lot of ways, more than one way, how you can get an answer, because that will just help you in the exam. If you have different roads, then it's easier than to get stuck into one road. Okay, and then the last one, that was B. Now I look at C. Express cos 2x in terms of sin square x. Okay, double angles, and you can again go to your formula sheet and hence show that. Okay. So in this case, this is my double angle, and let me just show you. Can I just remember cos is having so many, but now if they say express cos in terms of sin, so you will go to the sin one. Sorry, I want to actually take you there back, and I actually want to just make this a bit bigger. Then we don't have to every time. Okay, so basically, you can say cos 2, and if I want the sin 1, there it is, from your formula sheet. Okay, let's go back. Okay, so this is what I got there. So that's what I express in sin and hence show. So they really try to help you to get your mind in the correct way. Okay, and now I'm just going to do, so double angles. So therefore, I'm going to say 1 over cos 2x, okay, let's just say, because there, and show, there it is. So then I substitute this, did you see? Okay, then I'm getting this, okay, so the ones cancel out, so 2 said, and then I'm getting a half cosec squared x. I didn't integrate, they just say express it in, express as, okay. And now I will go, hence, using the results of A, find. So I know that this is equal to this, okay? And I remember again this, which I show you there. Cot is cosec. So cosec is going to be negative. Where am I now? Just there. The half is just a constant, so negative cot x plus c. And leave it like this. It's indefinite integration because there's no limits there, nothing. Okay, I'm going to do the same as I did in the previous, because this example is a lot of thinking, and I think especially this last few chapters is quite challenging. So I decided to do 2 videos every time because I think it's more complicated, and maybe the 2 videos will help you. Okay, just remember, stop it, try it, continue the video. And if you're checking the video and you cannot, you have to check the video the whole time, then the next day, before you go on, then just stop the video then again and see if you can do it on your own. Okay, if you can recall it from the previous day or the previous time. Okay, so I want you to do number 1 as well as number 2. And again, you can continue the videos as soon as you try it. Okay, let's start with number 1A. Read. Remember, because this is typical exam examples, Cambridge exam examples, it's mixed, differentiation, integration. Chapter 10, 11 and 12 is just flowing into each other with the previous knowledge of differentiation and integration as well as trigonometry. So it's 4, 6, 7, 10, 11, 12. It becomes a unit. Okay. Given that y, we write it down, is equal to tan 2x. Okay, and now again, you have to know your rules. Remember, as soon as I see this is differentiation. So I think, how did I differentiate this? It was just dy over dx is equal to remember, it's differentiation, that's why it's not a half, so it's 2 sec squared. And don't forget the 2x. Okay. Number B. Hence or otherwise show that, okay, there, it's 1 over 6 pi 0 6 squared 2x dx, and they want me to show. Okay. Now, in can I just, no, I think the printing mistake is there. I'll come to that. So now, I'm just going to remember that, as I said to you, they gave you actually, what is sec squared? I know that also. I know that is tan x. But it's just now integration, that's why it's a half. Differentiation, it's just the 2. Integration, the reciprocal, a half. And then it's going to be tan 2x. And it's going to be 1 over 6 pi, and it's going to be 0. And I'm going to substitute. So it's a half tan 2, and it's 1 over 6 pi. And then it's going to be, I'm substituting now the other one, minus a half tan, oh, this is going correct, tan 2, 0. Okay, so it's a half tan, I'm just going to put this, it's 2 over 3, so it's a third, so it's pi over 3 minus a half tan 0. Okay, as soon as I see pi over 3, pi over 6, I always go for my triangle. And I'm drawing it every time, I'm explaining it every time, so I think you have to know it by now. It's coming from the equilateral triangle. So I know that this was 2 and this was 1, and then this was square root 3. And then this was, it's 60, but it's pi over 3. And then this was 30, but it's pi over 6. Okay, so it's almost like the opposite. 60 goes with 3 and 30 goes with 6. Okay, now I can substitute. So it's a half. Now, if I come to tan pi over 3, so it's going to be square root 3 over 1, opposite over adjacent. Okay, square root 3 over 1. And don't forget, and tan 0, you have your, this is your tan graph. So what is tan 0? It's just 0. And the answer is going to be square root 3 over 2. That's going to be my answer. Okay, let's continue. What was the next one? Just move it a little bit down. It should otherwise show, okay, this is what I did there. And by using appropriate trigonometrical identity, find the exact value. Now, maybe in 2 years' time, it will not be, but now in the first print, I left out that 2. It's supposed to be 1 over 6, let's just write it, pi 0, and it must be tan square 2x. It must reflect to this top, and then dx. So please just take note if in the first print of that printing mistake. Okay, so if they go now and they say hence find it, so they want me to use all this knowledge. Okay, so let's just start. I'm going to say, okay, oh no, I'm so high that I cannot see anymore. I just start and then I'll move it up. Okay, so I'm going to say 1 over 6 pi 0 tan, and remember square 2x. Okay, that is going to be, remember they let me do something so that it helps me. Okay, so let's go back. And then we are going to see, okay, let's just see what I did there. 6 square x minus 1. Can you remember that the property is coming from there? I just want to see if I can find it now. Let's just go back. Previous. Okay, it's coming from there. So tan square, so if it's tan square 2x, it will just be 6 square 2x minus 1. So it's coming from there. So I'm just going to substitute it. And that was on page 527. Okay, so let's just go back. Okay, we move up a little bit. And it's going to be, okay, 6 square 2x minus 1 dx. Okay. Okay, and now I remember, let's see, 6 square 2x. Are you with me? What happened if I was substitute? It's almost, let's break it up. It's now actually, and the reason why I break it up, I want to use the top. So it's 1 over 6 pi 0. So if I say 1 over 6 pi and 0, it's actually, remember addition, I can do that, minus 1 over 6 pi 0, and then it's the 1. Are you with me? Okay, and this is actually also to dx. So I already have 6 squared 2x. Did you see there? 6 squared 2x to that boundaries is square root 3 over 2. Okay, so that was square root 3 over 2. Okay, now I must still, if I do this one, it's x, and it's going to be 1 over 6 pi and 0. So let's just see if I can finish this off. So it's square root 3 over 2 minus, okay, let's keep the bracket. And then I'm just going to say it's going to be 1 over 6 pi minus 0. And that is going to give me square root 3 over 2 minus pi over 6. And that is going to be my final answer. Okay, let's look at number C. So I'm going to do it here because I'm going to reflect on some of these things. So I'm going to, let me just write it down. I made it a bit smaller so that I can see the rest. So 1 over 6 pi, let's just, using the identity to find. Okay, so 1 over 6 pi, 0, then 1 over 1 plus cos 4x dx. Okay. Now, I said, don't forget there. Do you see? So, if I'm going to keep it, so say 1 over 6 pi and 0, 1 over 1 plus, and now I'm going to 2 cos square 2x minus 1 dx. Okay, so if I'm going to go further there, now I'm going to see that this one and this one will cancel out. So let's just go on. I still didn't integrate, so 1 over 6 pi, 0. So it's 1 over 2 cos square 2x dx. Okay. Now, don't forget, if you're going to take it up, so it's 1 over 6 pi, 0, and then it's going to be a half, and then it's going to be 6 squared 2x dx. Okay. So basically, I'm ending up with this 6 squared 2x. Do you see? 6 squared 2x is just the half in front. So I can basically go and use this part. I think it's also coming there from the top that I use 6 squared 2x. So I can go and I can say, okay, that basically all that I'm going to do is if I'm integrate, after I integrate, I don't even have to do it. I can just say it's equal to a half because I know that it's going to be square root 3 over 2. And then my final answer is going to be square root, oh sorry, that was not supposed to be part of the, okay, square root 3 over 2, and my final answer is going to be square root 3 over 4. Let's start number 2. So it's going to be sec square x plus sec x tan x is equal to 1 plus sin x over cos square x. Okay. Just like identities, we start with the left-hand side, usually, not always, and we rewrite it first. Okay, and now we're going to start simplifying it. So let's go to cos and sin. So it's 1 over cos square x plus 1 over cos x, and then it's going to be sin x over cos x. Okay, take note there's a positive. So it's 1 over cos square x plus sin x over cos square x, and that will give you 1 plus sin x, well, let's just get that correct, sin x over cos square x, and then that is equal to the right hand side. And that's a nice way of presenting it. Okay, but that was number A and the first one. Just let's number it correct. Now, hence, prove that sec square this is equal to this. Okay, always start with the statement as it's given. So it's going to be sec square x plus sec x tan x, and that's 1 over, let's just complete that, sorry, 1 minus sin x. Okay, now don't forget, I already have that this is equal to this. So basically it will also be, so I basically just substitute it here. So I go and say 1 plus sin x, I basically just substitute this over cos square x. Okay, so it's equal, okay, let's just first go with the identity. That's now my identity after I simplify. Now, don't forget, I'm starting again with the left-hand side. And the left-hand side is 1 plus sin x over cos square x. Okay, and now I just want to see if I was, yes, cos square x, don't forget, I want to go to sin. So your basic is the nice one, where I say, okay, remember, sin square x plus cos square x is 1. So cos square x equals 1 minus sin square x. So it's going to be 1 plus sin x over 1 minus sin square x. And that is going to be 1 plus sin x over 1 minus sin x, difference between two squares, 1 plus sin x. Put a bracket, cancel, and that's equal to 1 minus sin x, which is equal to the right-hand side. That's how I do that one. Okay, now I continue. What is the question saying now? So that was now the second one. By differentiating 1 over cos x, show that. So they help you. They really help you by writing that. Otherwise, they could have just said, and it's differentiation. It's not integration, differentiation. Just for the interest in this one is more or less the same question. Coming out of question paper, so they like asking that. Okay, but let's continue here. Let's see. Okay, first I'm going to make it a bit smaller so that we can see everything at the end. So I will continue here. Okay, so let's just start, and I'm at B, by differentiating. Okay, now as soon as I differentiate d over dx, and it's 1 over cos x, and I differentiate to x. Now just think of the quotient rule. That's what I'm going to do. It's division. So how is the quotient rule working? Can you recall? It's going to be, I rewrite the denominator, I differentiate the numerator, minus. I rewrite the numerator, I differentiate the denominator. And then I square the denominator. Okay, so basically I differentiate it. Now, don't take, and usually, don't forget, if you differentiate a 1, it's 0. It's a constant is going to be 1. It's differentiation, it's integration. So it's actually going to be cos x, and then 0, minus. Okay, and then it's going to be, what is going to become with cos x? It's going, remember, it's differentiation, so it's going to be negative sin x. Okay. This you can look on your formula sheet. It will always also be there. And it's going to be over cos square x. Now, don't forget that this is going to be 0. And this is going to be sin x. This is going to be cos square x. Okay. Now, if you come to a point and you wonder, oh, what did they ask? So, by differentiate, show that set, because that was equal, that this is this, after I differentiate. Okay, but I'm now, just see what I have. I have now, I can break it up into sin x over cos x multiply 1 over cos x. And that is going to be tan x multiply sec x. And that, if I go back to the question, where it is now. Okay, by differentiating, show that sec x tan doesn't matter the order. That's basically number B. That's what I got. Okay, and now I'm just going to make a line just to give myself a little bit of space here. Okay, and then I'm just going to do number, what, the last one. That's number C. Okay, so using the results of part A, the first one, okay, and B, find the exact value. of this. Okay, so let's start with number C. Now it's going to be, and as I said, I'm going to write it here. This is C. There's my int, and it's a quarter pi, and it's 0. And if I look there, there is my, so it's 1 over 1 minus sin x dx. Okay. Now, don't forget, where is it? Here. Yes. This statement is equal to this statement. Okay, so can you recall? So now I can go and I can keep the boundaries there. So the limits, quarter pi, 0, but now I substitute that in. So I'm going to say, it's going to be sec square x plus sec x tan x dx. I'm going to integrate this. Okay, now if I integrate, remember the rules again. Sec squared, very easy, it's just tan x. Okay, now remember this. Okay, let's just see where did I found this one now. Okay, yes. Can I show you here? Do you see this? Is the same as this. Okay, and that it's now actually reversing back, because that's what integration. When I went like, okay, I want to take red. That's what I differentiate. And when I'm going to reverse back, I'm going to integrate. So basically this, in the place of this, because I'm integrating, I can write 1 over cos x. Are you with me? So plus 1 over cos x. And that's going to be a quarter pi and 0. And then this, okay, now I'm going to substitute. So tan, it's pi over 4 plus 1 over cos pi over 4 minus tan 0 plus 1 over cos 0. Okay, and now tan pi over 4, don't forget, I can quickly make you again the isosceles, so it's 1 square root 2, and that was pi over 4. So what is tan pi over 4? Tan, it's 1 over 1, okay, so that will just be 1, okay, plus. Now can you see, so now I don't have to work with sec. Otherwise I have to work with the sec graph. But because I wrote it like this, what is cos? Cos, adjacent over hypotenuse. So it's 1 over square root 2. Are you with me? What is tan 0? I think I showed you a lot of times that. So it's 0. What is cos 0? Be careful. Cos is coming from there. Can you recall? So what is cos 0? So it's plus 1, but that is 1. Okay. Then I'm going to just have 1 plus, remember, and I'm doing it now long, it's not necessary, okay, minus 1. And that is going to be now, that one, okay, sorry, this is now unnecessary long. That cancel, and the final answer is just square root 2. Very long, but this is typical exam questions.